channel.
On the last video, you learned about zero and negative exponents.
Well, in this video, we will be teaching you about rational exponents.
But first, what are rational exponents?
Rational exponents are exponents that are fractions.
Well,
let's get started.
Have you noticed any similarities between column A and column B? Well, their similarities is they have the same value.
And the rule for rational exponents is that the nth root of b will always be equal to b raised to 1 over n, where this is the index, this is the radicand, and this is the radical sign.
And the index will always be placed as the denominator. Here are some examples on how we write exponential expressions to radical notations, and vice versa. And now, we will start by changing these exponential expressions to radical notations.
We will be using the word b raised to 1 over n is equals to the nth root of b. We will be placing 20, the base, as the radicand and put it inside the radical sign. The next one, we should put 32 as the base and 3 as the index. Then, we should put the radical sign. The same goes with a, b, and c raised to 1 over 4, where we put 4 as the index. Also, in 10t raised to 1 over 5, we will put the 5 as the index and 10t inside the radical sign.
Now let's move on to changing radical notation to exponential expressions.
Now, we will be using the nth root of b is equals to b raised to 1 over n. The square root of 81 is also equal to 81 raised to 1 over 2. The cube root of 8 is also equal to 8 raised to 1 over 3. The fourth root of 256x is also equal to 256x raised to 1 over 4. And the fifth root of 243 is also equal to 243 raised to 1 over 5.
Now, let's try a more difficult example where we can extend the definition of b raised to 1 over n, where the rational expression has a numerator other than 1, namely b 1 over n is also equals to b raised to m over n.
The first step will be writing 16n raised to 1 over 3 inside the parentheses. Then, raising it into 2. We multiply 16 and 1 over 3 to 2, which will be equal to 16n raised to 2 over 3. The next one will be 1 over the fifth root of f to the fourth, where we should put the 1 over the f raised to 1 over 5 raised to 4, where we multiply 4 times 1, and it will be equal to 1 over f raised to 4 over 5. The next one would be writing 24, the base, inside the radical sign, then raising it into 4, then putting the index 5. The next one will be putting 25 inside the radical sign, then raising it into 3, then putting the index 6.
Now let's move on simplifying the rational expressions.
First, we should write 64 raised to 1 over 3, then raise it into 2. We should find the cube root of 64, which is 4, then raise it into 2, equals 16. Now, we will be writing 25 raised to 1 over 2 inside the parentheses, then raise it into negative 4, The square root of 25 is equals to 5. Then, we should raise it into negative 4. It will be equal to 1 over 625.
Now in this example, we'll be using the product rule for exponent where x raised to n times x raised to n equals x raised to n plus n.
In this problem, x is equals to 5. So, you should put 3 over 2 plus 1 over 2, which will be equal to 5 raised to 2 equals 25. The same will go with the next one. 27 would be the x. Then, raise it into 4 over 3 plus 2 over 3, which will be equal to 27 raised to 2 or 729.
Now let's proceed on applying the second power rule for exponents, where x, y raised to m is also equals to any of these examples.
The second power rule of exponents states that x, y raised to m is equals to x raised to m, y raised to n. And x over y raised to m is equals to x raised to m over y raised to n. First, let's put 3 times 27 inside the parentheses. Then, raise it into 1 over 2. 3 times 27 is equals to 81 raised to 1 over 2, which is equal to the square root of 81. The square root of 81 is equals to 9.
Next, we will be applying the quotient rule for exponents, which is x raised to m over y raised to n equals to x raised to m minus n.
We follow the rule x raised to m over y raised to n is equals to x raised to m minus n. We copy the base 64, then subtract the numerator's exponent from the denominator's exponent, which is 1 over 2 minus 1 over 3. To subtract these exponents, we should have the same denominator, making it 3 over 6 minus 2 over 6. The difference between 3 over 6 and 2 over 6 would be 1 over 6, which will be equal to the 6th root of 64, or 2.
Now, for the last example, we will be applying the first power rule of exponents, where x raised to m raised to n is also equals to x raised to m times n.
In this example, we copy the base 4, then multiply the exponents. 6 times 1 over 2 will be equal to 4 raised to 3. 4 raised to 3 is equals to 64.
Trouble, 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 hey.